We have practice exercise 16.11. You're not watching a duplicate video if you watched the last one and we solved it in the normal mode. This we're doing a little bit more fun. We're going to solve it with recursion. So if you want to see how to solve it normally and the proper way it wants it to be solved, go check out that previous video. It's in the playlist link below the like button. It's going to be this code right here. If you want to have some fun with your life though, and well, I don't know about fun, but if you want to solve this with recursion, we can do so in this video. If you want an explanation of the problem, watch the first part of the previous video. We're just going to jump straight into it here. We want a public void compress. We're taking int n as parameter, and this is essentially going to just compress our list however many times it wants to. So to do this, we need a list node, and we're going to call it current. We'll set it equal to this front value, so we can just have it right here. List node current is equal to front, and then after this we are going to want to push our list into another method. I'm going to break this up as much as I can so it's super simple to read, look at, and understand. So we want to pass in current and pass in our n values into this method that's going to be recursive. This recursive method is going to represent our while loop right here. We're going to do a compress, and I'll just call this R1. We'll take our current and n as parameters, and that'll be pretty much it for the actual compress method. So inside of here, we can write a private void because only the compress method is going to access it. We'll have compress R1, that'll be the name, and we're going to pass in a list node n, and then we're also going to pass in, let's call this current, and pass in an integer n. There we go. Inside of here, since this is representing our while loop, we're just going to have one base case, and we're going to want to run this if our current does not equal to null. That's pretty much it. That's all that's required. Now, if we do this, we are going to want to start the compression. So this one is basically going through our lists. We need another loop to actually compress this n many times. So we're going to need another loop inside of here, which is going to be represented with another private recursive method. So compress R2. Now, we know we need a for loop. So with our list node that we're going to pass in, which is called current, and our n that we're going to pass in, we're also going to pass in a 1. And that's basically just going to be the start of this for loop. That's what it's going to represent. We're going to come back to this. We're not done coding it by any means, but let's close this off for now, and we'll keep with the flow of the program. We want a private void compress R2, and we want to take all of these in here. When we're passing in variables, you don't need to assign them. Totally forgot about that. It should just be current n1. Up here, though, is where you need to assign them. List node current n1. You need to assign this to a variable though, so let's make this an int counter as well. And this is going to be the counter for when we go through this for loop. So when we are going from a for loop to recursion, it changes to be a base case or a case statement. In our scenario, it's going to be the base case. We're going to say if our counter is less than 0, or less than n, sorry, we're going to be inside of here. So we're basically going to continuously go through this. Since it is recursion, this is essentially the loop. We're going to keep going through this as long as counter is less than n. So now we can write the code that's going to be inside of here, and I'll show you how to do this with a little friendly diagram. With our diagram here, we can kind of see what we want to do. We know we have these variables, and I'm looking at the first example that was given to us. They're linked together like this because it is a linked list, and we have our current pointing to the front data, which is this right here. We're going to want to essentially add these two together. So to do this, what we're going to have is our front.data, which will be represented with our current.data plus equals, and then we're going to have our current.next.data because we want to get the data that's stored in this next value. This is the next part. So 2 and 4 are going to be added together. Once we do this, we're going to have 6, 4, 18, and so on and so forth. Remember, these are all going to be linked. I'm emphasizing this because the linkage is super important. We'll see why in a second. Now, we need to actually have the list go from the 6 to 18 now, completely bypassing this 4, and it's going to get removed from our list because we already added it in. So what we can do is, since this is the current next pointing to 4, we're going to reset our current dot next. So we can say current dot next is equal to current dot next dot next. And that means that this next is no longer pointing to this next. It's going to be pointing to the next next, which is our 18. After we do this, our list is going to be like 6, 18, and then so on and so forth. And that's pretty much it. Now, the problem is the pointer is still pointing to our 6 right here, and so we are going to want to move it to this next one, so which would be 18, because we only run this twice. If we wanted to run it longer than twice, like 3 times, we would need to go back into our compress R2 method. So let's actually code for that, because that's a possibility that might happen. Let's do the recursion for this. The recursion is going to be the next part. So what we're going to want to pass in here is going to be our compress R2, where we have our current value being passed in, right? That's going to be this 6 value, so we can add it to the next thing. Our n doesn't change, so we're still passing that in. And we have to pass in our counter, but our counter is going to be incremented every time we do this, so we need to do a counter plus plus up here. And that's pretty much going to be it. Now I've closed off our method right here because we're pretty much done with it. All we have to do now is move this pointer right here over to this next one. But we're going to do this inside of this method up here. So we're done with our compress R2. We've come out of our loop. We've done everything we need to do for the compression part. Now we just need to move the pointer over. So all we need to do is set our current value, current equal to current dot next. And so what that's going to do is it's going to move this pointing to our current to pointing at this one right here, since we've already done the first one. Now we need to do the recursion and go back into compress R1. So compress R1, we need to pass in our current list node. So what we can do actually is take this current dot next. You don't even need this line right here actually, and then press an N inside of here, and then close this off with a semicolon. Let's submit this. And if you have any questions for the 16.11, leave them in the comments below if you want any more clarification. And if you want more practice problems, they're in that playlist link below the like button. That's going to be it. This is passing its test. This is the original code. This is the recursive code. I was about to say fun recursive code, but it's up to you. And that's it for 16.11. Have a great day.